Hello everyone, this is fifth part of organic chemistry. In this video, we are going to cover definition of isomerism, types of isomerism, and properties of isomers. Now covering definition of isomerism, the compounds having same molecular formula but different molecular arrangement or different structural formula or having different structures in three-dimensional space are called as isomers, and the phenomena is known as isomerism. Now covering types of isomerism, there are following two types, that is structural isomerism and stereoisomerism. In case of structural isomerism, the compounds have same molecular formula but they possess different structures in two-dimensional plane. The isomers are called as structural isomers and the phenomena is regarded as structural isomerism. Structural isomerism arises due to difference in the manner of linking of atoms in two-dimensional space. Now, in case of stereoisomerism, the compounds have same molecular formula but different structures in three-dimensional space. The isomers are called as stereoisomers and the phenomena is known as stereoisomerism. Stereoisomerism arises due to difference in orientations of atoms in three-dimensional space. Now covering types of structural and stereoisomerism. Structural isomerism is further subdivided into following 6 categories. First one is chain isomerism, second one is position isomerism, third one is functional isomerism, fourth one is metamerism, fifth one is tautomerism, and sixth one is ring chain isomerism. Now stereoisomerism, it is further subdivided into two categories. First one is geometrical isomerism and second one is optical isomerism. In this video, we will cover chain isomerism and position isomerism in detail, and for reference geometrical isomerism as it is according to the latest board syllabus. So our first type of structural isomerism is chain isomerism. The compounds having same molecular formula but different arrangement of carbon atoms in the main chain or different number of carbon atoms in the main chain are called as chain isomers, and the phenomena is known as chain isomerism. Now taking up example of chain isomerism, suppose we are having a compound with molecular formula C4H10. It means in the compound there are 4 carbon atoms and 10 hydrogen atoms. As we can see in our first case, we are having a straight chain of 4 carbon atoms and hydrogen atoms are attached to that chain. But in our second case, there are 3 carbon atoms in a straight chain and 1 carbon atom is branched on second position. So, in our first chain, there are 4 carbon atoms in the main chain, but in the second case, there are only 3 carbon atoms in the main chain. And since in this case, there is difference in the number of carbon atoms in the main chain, that is why it falls in the category of chain isomerism. Now taking up another example of chain isomerism, Suppose we are having a compound with molecular formula C5H12. In our first case, we are going to make a straight carbon chain. Since this carbon chain is straight or normal chain, that is why its common name is N-pentane. N for normal chain and pentane for 5 carbon atom straight chain attached with single bonds between carbon atoms. In our second case, we are having 4 carbon atoms in the main chain and this branching on the second carbon atom. In this case also, the molecular formula is same C5H12, but there is difference in the arrangement of carbon atom in the main chain. Since in this case, there is branching only on one side, its common name is isopentane. In our third case, there are only 3 carbon atoms in the main chain and there are branching from both the sides. That is why the name neo is given to this compound and its common name is neopentane. In all the 3 cases, there is difference in the arrangement of carbon atoms in the main chain. That is why it falls in the category of chain isomerism. Now our second type of structural isomerism is position isomerism. The compounds having same molecular formula but difference in position of either functional group or the substituent group or double bond or maybe triple bond are called as position isomers and the phenomena is known as position isomerism. Now taking a first example of position isomerism, suppose we are having compounds with molecular formula C4H9Cl. In this case, chloro substituent group is present. Now as we can see in our first case, we have 4 carbon atoms in the main chain and chloro group is attached to the first carbon atom. Its name is 1-chlorobutane. In second case, there are same 4 carbon atoms in the main chain but chloro group is attached on the second carbon atom. Its name is 2-chlorobutane. In both the cases, number of carbon atom in the main chain is same, that is 4, but there is variation of position of substituent group chloro. In first case, it is on first carbon atom and in second case, it is on second carbon atom. So because of the difference in the position, these compounds fall in the category of position isomers and the phenomena is known as position isomerism. Now taking up example 2 of position isomerism, suppose we are having compounds with molecular formula C5H11OH. In this case, OH, that is alcoholic functional group, is present. As we can see, in all the 3 cases, the number of carbon atom in the main chain is same, that is 5 carbon atoms. There is variation of only the functional group OH. In first case, it is attached on the first carbon atom and the name is pentane 1-ol. In the second case, it is attached on the second carbon atom and the name is pentane 2-ol. In third case, OH group is attached on the third carbon atom and its name is pentane 3-ol. As we can see, in all the 3 cases, number of carbon atom in the main chain is same, but there is variation of position of the functional group. That is why all these are example of position isomers and the phenomena is position isomerism. Now taking up third example of position isomerism, suppose we are having compounds with molecular formula C4H8. As we know that CnH2n is general formula for alkene, it means in this case also, which is having 4 carbon atoms and just double number of hydrogen atoms, there is presence of double bond. In first case, that double bond is attached to the first carbon atom, and in second case, that double bond is attached to the second carbon atom. Name of the first compound is but1-ene and name of the second compound is but2-ene. Since in this case there is variation in the position of double bond, that is why these are also examples of position isomers. Now taking up geometrical isomerism, which is a type of stereoisomerism. So the compounds having same molecular formula but differ in the arrangement of atoms around the carbon-carbon double bond are called as geometrical isomers, and the phenomena is known as geometrical isomerism. It is of two types, that is cis and trans. In case of cis isomer, the same groups are attached on the same side of the carbon double bond carbon. But in case of trans isomer, the same groups are attached on the opposite side of carbon double bond carbon. As we can see in our first example, Br, that is bromo group, both are attached on the same side of carbon double bond carbon. But in second case, that is trans isomer, bromo group are attached on the opposite side of carbon double bond carbon. Now covering properties of isomers. Isomers possess same chemical properties but different physical properties. Chemical properties of a compound depend upon its composition, whereas physical properties depend upon the structure of the compound. As isomers possess same molecular formula, that is their chemical composition is same but different structures, that is why they possess same chemical properties but different physical properties. Thank you for watching this video. Please like the video, share it and subscribe to my channel. Thank you.